Here's my original graph of the function. Here's my first derivative. Here's my second derivative. Remember, when my graph is increasing, that means it has a positive slope. So take a look at my first derivative. That's the slope of my original graph. So my first derivative from negative infinity all the way to this point right here is positive because my graph is increasing. Then between this maximum point and this minimum point, my graph is decreasing. And you'll notice that the first derivative between those two places is negative. It has a negative slope, so it's decreasing. Then my graph is increasing again on this final interval from the minimum point to infinity. And if I come up here to my first derivative, I notice that my first derivative is increasing on that interval, or sorry, positive on that interval, which indicates that I have a positive slope on my function. So this next one, this is my second derivative. Notice that my second derivative, that's going to indicate concavity because here's my graph. It is concave down all the way over here to this part of my graph. Right here, I'm going to switch from concave down to concave up, and when that transition happens, we call that an inflection point. So this inflection point happens when the second derivative is 0. So the second derivative is 0, and the sign of my second derivative goes from negative, indicating that it's concave down, to positive, indicating that my graph is concave up. But there's one more thing I can tell from my second derivative. Recall that when your first derivative of the graph is equal to 0, then I know that I have a relative max or min at that point on my graph. But I'm not certain if it's a relative max or min, so I always have to verify it. My first derivative test will tell me, based on whether or not my first derivative is going from positive to negative or negative to positive, I can tell whether or not that point is a max or a min. But I can also tell from my second derivative, and it has to do with the sign of the second derivative. So when I find that critical value, I can take my second derivative and look at the sign of my second derivative. If my second derivative is positive at that critical value, I know my graph must be concave up. If it's concave up, then that point must be a relative minimum. Likewise, when my first derivative is 0, I know I have a relative max or min. I can look at my second derivative to see whether or not it's a max or min. So on my second derivative here, because my second derivative is negative at that critical value, I know my graph is concave down, and concave down means that that critical value is a maximum.